Hi everyone, it's Math with AUB for the preparation of IBA direct tax especially and the jobs from 5 to 15, preparation of IBA and GAT. I have been advised to explain the question several times, read the question several times in order to give clear view what the question is, then to the solution. Our topics are today, I have selected some questions from logarithm, geometry function and surds. Let's see and find out. Our question number 1, evaluate means find the value of evaluate means find the value. Evaluate means find the value. A, log of 4 to the base 2. Log of 4 to the base 2. Log of 4 to the base 2. Or one can write log log of 4 to the base 2. Log of 4 to the base 2. How to read that or how to simplify that? What should be the power of 2 to get 4? What should be 2 raised to? What should be 2 raised to get 4? Suppose 2 raised to x is equal to 4. This is known as logarithmic form and it is known as exponential form, exponent form, exponential or exponent form. Sometimes we are asked, write this one into logarithm form, that is the logarithmic form. Sometimes logarithmic is given, we are asked to write exponential equation. Now we have to solve. What should be the power of 2 to get 4? What must be the power of 2 to get 4? 2 raised to what power? Suppose 2 raised to x power is equal to 4. 2 raised to x. 4 can be written as 2 times 2. 2 raised to x. Bases are same, they are multiplication. It can be written as 2 raised to 2. 2 raised to. As this implies that bases are equal, therefore powers are equal. Bases are equal, therefore powers are equal. By virtue of equality, x is equal to. One can easily verify if 2 raised to 2, if value of x is 2, put here, 2 raised to gives us 4. 2 raised to gives us 4. Log means power. What should be the power of 2 to get 4? What should be the power of 2 to get 4? Okay, move to another question. Here it is log of 1 over 10. Nothing has been mentioned in the base. Our second question is log 1 over 10. Nothing mentioned means base is 10. If nothing has been mentioned, then base is 10. If nothing has been mentioned, it is tantamount to log of 1 over 10 to the base 10. No base is mentioned in log means it is 10 base. It has 10 base. Understood. It has 10 base. Same 10 raised to what power to get 1 over 10? 10 raised to what power to get 1 over 10? 10 raised to what power, suppose x power, to get 1 over 10? No base is mentioned in log means base is 10. I have mentioned. For your clarity, I have mentioned 10. Now 10 raised to what power to get 1 over 10? 10 raised to what power to get 1 over 10? What should be the exponent of 10 to get 1 over 10? It's really very easy. Here it's positive power. Here 10 is in the numerator and here 10 is in the denominator. Making the life simple, drag the 10 into numerator. It will be raised to negative power. 10 raised to positive 1 can be written as 10 raised to negative 1. Now we can compare 10. Both bases are 10. Bases are equal, therefore powers are equal. This implies that x is equal to minus 1. X is equal to minus 1. One can verify by plugging in the value of x. Here value of x is 10 raised minus 1. This can also be written as 1 over 10 raised to positive 1 raised to 10 over positive 1. Log means no base is mentioned, base is 10. No base is mentioned, base is 10. Now 10 raised to what power to get 1 over 10? 10 raised to what power to get 1 over 10? 10 raised to what power to get 1 over 10? I have written suppose 10 raised to x. 10 raised to x to give 1 over 10. To making comparison, quantities must be compatible. There is 10 in the numerator, here 10 is in the denominator. To make them compatible, I have dragged 10 power 1 from denominator to numerator. I have raised to 10 as negative 1. Now both are compatible, 10 10, so x is equal to negative 1. Question number C and D, they are just extra practice for you. I am solving one and leaving one for your homework. Which one? I am taking the D one. C is for your homework. D. Log of 27 to the base 3. Log of 27 to the base 3. Log of 27 to the base 3 means 3 raised to what power to get 27? 3 raised to what exponent to get 27? 3 raised to what power to get 27? 3 raised to x. 27 can be written as 3 times 3 times 3. 3 3 the 9, 9 3 the 27. Bases are same, they are multiplication and the powers. 3 raised to x is equal to 3 cube. As bases are equal, this implies that powers are equal. X is equal to 3. X is equal to 3. So our answer is, in that case, x is equal to 3. X is equal to 3 in that case. One can plug in the values to verify without solving. 3 raised 3 is equal to 3 into 3 into 3. It will become 3 3 the 9, 9 3 the 20. 3 3 the 9, 9 3 the 27 in that case. Okay. Moving towards second question, also based on log. Here, all the three famous properties of log to be utilized to get to the answer. Let's see and find out how. E. Log of 2 to the base 8 less log of 4 to the base 8. Here, one can utilize the three properties of log. Here, addition can be merged into a single log in multiplication. Let me write simple property for you. Log A plus log B. If bases are same, this one can be written as log 1 times A times B. A times B. From addition, they can be merged into multiplication. From multiplication, they can be split into addition, and vice versa. Here, base is 8. Here also base is 8. Applying this property, right? Log 8 same, one time multiply these. This is RA, this is RB. 2 times 4. 2 times 4. 2 times 4 means log of 8 to 4, that log of 8 to the base 8. Log of 8 to the base 8. Now it is already solved question. Now what should be the power of 8 to get 8? What should be the power of 8 to get x? 8 raised to what power to get 8? Obviously 8 raised to 1. In that case, x is equal to 1 is the answer in that case. X is equal to 1 is the answer in that case. What property we have utilized? Always keep in mind log A times B times C. Multiplication can be split into separate log using addition. Log A plus log B plus log C, provided that they have same basis. Provided that they have same basis. Provided that they have same basis. Okay. From addition to multiplication. From addition to multiplication. Let's see. What about subtraction? What about subtraction? Let's see and find out. Our next question is log of 60 to the base 2. Log of 60 to the base 2 minus log of 15 to the base 2. Look, base must be same in that case. 2 2. 2 2. 2 2. Nothing mentioned, meant 10 10. Log base is same. Here it is in division. Sorry, it is in subtraction. Log A over B. It can be written as log A negative log B. Subtraction can be merged into division. Write log one time, write log one time, divide with the negative base, log A over B, log A over B here, this is our A and this is our B. We can merge this as log of A over B to the base 2, log of A over B to the base 2. Here A is 60, B is 15. A is 60, B is 15. Let me plug in the values. Log of 60 over 15, log of 15 over 15 to the base 2. Applying table 4 times, we have log of 4 to the base 2. We have log of 4 to the base 2. We have log of 4 to the base 2. Simple. 2 raised to what power to get 4? 2 raised to what power to get 4? 2 raised to what power to get 4? Obviously, 4 can be written as 2 square. 4 can be written as 2 square. Bases are equal, therefore powers are equal. X is equal to. X is equal to is our answer. X is equal to is our answer in that case. One more property is missing. From addition to multiplication, from division to subtraction and vice versa, from subtraction to division. Then if there are some coefficients are present like this, let me write the question very clear for you, then let me explain. Our next question is, let me, it's same 36 divided by 12, 4 log 3, 3. You can solve on your own. I am solving H for you. H, an elegant question. Log of 4 to the base 3 minus 2 times log of 3 to the base 3 minus 2 times log of 6 to the base 3. That is the question. Log of 4 to the base 3, log of 3 to the base 3, log of 6 to the base 3. Here, that is something new for you too. How to handle these coefficients? How to handle these coefficients? Something new for you. Something new for you. They can be written as coefficients can be converted to powers. It can be written as 3 square. This 2 will be shifted to the power as well as this 2, as well as this 2. It will become log 6 square to the base 3. It is log 3 square to the base 3. This coefficient can be converted to power. This coefficient can be raised to power. This coefficient can be raised to power. This coefficient can be raised to power and vice versa. Both way it is applicable. So same log of 4 to the base 3. So it is log of 3 square to the base 3. Switch over this 2 as power. Take this 2 as a power. Coefficient can be converted to power. Similarly, here minus log of 6 square to the base 3. 3 square means 9. 6 square means 36. We have log of 4 to the base 3 negative 3 square. Log of 9 to the base 3 minus log of 36 to the base 3. Now don't forget negatives. Negative logs can be written in division. I can merge this once for all. Log of 4 divided by 9 as well as 36. Have a close look at this step. This log is in negative. This is also minus. Having bases same. That is our prerequisite. It must be met, then apply this property. Base is same 3. It is positive 1. I have written in numerator. Negative 1. This base is also in denominator. This is also in denominator. Applying table. 4 9 the 36. I have log of 1 over 9 into 9 to the base 3. Log of 1 over 9 times 9 to the base 3. 9 9 the 81. It's 1 over 81 to the base 3. Now same 3 raised to what power to get 1 over 81? 3 raised to what power to get 181? 3 raised to what power to get 181? It can be written as 3 raised to x to get 1 over 81. 3 raised x to get 1 over 81. 81 is a purely power of 3. It can be written as 3 times 3 times 3 times 3. 3 is the 9, 9 is the 27, 26 7 the 81. Don't spill anything. 3 raised x 1 over 80. Sorry, 3 raised 4. 3 raised 4. Now take this 3 raised 4 to numerator. It will become 3 raised x is equal to 3 raised to negative 4. 3 raised to negative 4. Bases are equal. So our eventual answer in that case is x is equal to minus 4. X is equal to minus 4. Same 3 raised to what power to get 1 over 81. Factorize 81 4 times. 3 raised 4. Here 3 is in numerator, here 3 is in denominator. To make them compatible, shift this 3 raised 4 to the numerator as 3 raised negative 4. 3 raised negative 4. Compare the power. Bases are equal, therefore powers are equal. X is equal to minus 4 is our answer in that case. Here, some letter based question in of log, some letter based question of log, they are also same by the virtue of definition. Let's see and find out. Let me read this first. Still, log of root a to the base a. Log of root a to the base a. Story remains same. Keep your life simple. Always stuck to the definition. Always stuck to the definition. Log means power, simply a raised to what power to get root a. A raised what power? Suppose x power. A raised to what power to get root a? A raised x. Root a can be written as a raised 1 over 2. A raised 1 over 2. Bases are equal. This implies that powers are equal. X is equal to 1 over 2. So 1 over 2 is our eventual answer in that case. X is equal to 1 over 2 is our eventual answer in that case. Next question, let's see and find out. Log of 1 over a cube to the base a at the base a. Log of 1 over a cube to the base a. Simply by definition, a raised to what power to get 1 over a cube? A raised to what power? A raised to what power to get 1 over a cube? A raised to what power to get 1 over a cube? Making bases compatible, drag a cube into a numerator. A raised x, a raised 1 over a cube can be written as a raised negative 3. A raised negative 3. Bases are equal, therefore powers are equal. X is equal to minus 3 is our answer in that case. Is our answer in that case. Find the question of log. Log of a square to the base root a. Log of a square, log of a square, log of a square at the base root a. So it one can be written as root a raised to what power to get a square. Let me check the angle whether we are in frame or not. It's cool, still a step also. Let me solve this one here. Okay, let me erase first these quantities. Final question of log. Log of a square to the base root a. Log of a square to the base root a. It means root a raised to what power to get a square? Root a raised to what power to get a square? Making life simple, root a means 1 over 2. A raised 1 over 2 times x is equal to a square. This one can be written as a raised x over 2 is equal to a square. Bases are equal, therefore powers are equal. Bases are equal, therefore powers are equal. We have x over 2 is equal to 2. X over 2 is equal to. Shift from denominator to numerator, from division to multiplication. X is equal to 2 times 2. X is equal to 4 is our answer in that case. X is equal to 4 in that case. X is equal to 4 in that case. Means root a raised to 4 to get a square. Root a raised to 4 to get a square. Simple as that. Moving towards some geometry questions. However, they are simple enough. Let's step to definition to solve them. Question number 1 is based on square. Square, its perimeter, its diagonal, and its area. Area. Let's see and find out. Square. I'm not good at drawing. Square means all sides equal. Suppose it is x, 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 it's x. Area is given by area of square. Side square. Side means x square. In case of square, each dimension, each side is equal to x. That's formula for area. What about perimeter? Perimeter stands for sum of all sides. Perimeter stands for sum of all sides. Sum of all sides. There are x plus x plus x plus x. Means 4 times x, or one can write 4 times side. 4 times side. What about diagonal? What about diagonal? Let's see and find out. This line that split the square into two equal rectangles is known as diagonal. Whether to draw this line, whether to draw a line in that fashion, it's okay. They are both equal in length. They are both equal in length. Now look at this. This is our diagonal. This is our diagonal. Each angle is of 90. This is also 90. Have a look. Opposite to 90, this diagonal is also called hypotenuse. If we stuck to this triangle only, let me draw the triangle out of this. Now it's x, it's also x. From triangle point of view, it is our hypotenuse. From triangle point of view, it is our hypotenuse. From square point of view, it is our diagonal. In that case, diagonal is equal to hypotenuse and hypotenuse is equal to diagonal. Applying Pythagoras theorem. Opposite to 90, it's our hypotenuse base perpendicular. Applying Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. So I have hypotenuse only h, base is x, as well as perpendicular is x. X square plus x square, it will become 2x square. X square, it is 2x square. Getting rid of square, taking the square root, both sides, h square is equal to root 2x square. This gives that h is equal to 2 is not a perfect square, remains root. X square is a perfect quantity, 2 raised x. 2 remains in square root, x square means x. So our diagonal is given by, in that case, root 2 times the side. Root 2 times the side, or diagonal is equal to root 2x. Root 2x. Root 2x. Now we have good idea. What do you mean by area? Area is given by side square. In that case, length and width both are equal. It is square. Square means every dimension. Dimension means length is equal. Perimeter, sum of all sides. 4 times side, yeah, 4x. What about diagonal? Taking diagonal applying Pythagoras theorem, we have root 2 times side. Root 2 times side. We are asked to find all these quantities when side is equal to 4. When side is equal to 4. So area, value of x is 4. Area of square, side square. Area will become 4 square. 4 square means, pass me the black marker. Fill this one as well. So area of square is or for the 16 square units. The units are mentioned centimeter. So it will become centimeter square. This is our area. What about perimeter? 4 times the side. In case of square, 4 times the side. 4 times the side. Or one can simply add up like a child, x plus x plus x, 4 plus 4 plus 4. 4 times 4, we have perimeter is equal to 16. Next, we are asked to find the length of the diagonal. Length of the diagonal is given by root 2x. Root 2x. So diagonal is equal to root 2x. Length of the side is 4. 4 times root 2 is the length of the diagonal. 4 times root 2 is the length of the diagonal in that case. Next question, it is same. Here it is square. Square means each side equal. And the next question, same things we have to find out, but based on a rectangle. Rectangle. Let's see what sort of variation comes. Let's see and find out. Let me erase this first. Question number 4. That I think 3. Length of the diagonal. Here we have a rectangle with dimensions 8 and 6. 8 opposite sides are equal. It's 6, also 6. Each angle of rectangle is of 90, as well as each angle of square is of 90. It is of, if it is of 90, then for finding diagonal we can apply Pythagoras theorem. This is our diagonal, also hypotenuse. Applying Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. Here hypotenuse or diagonal same thing. Base is 8 square, perpendicular is 6 square. So h square is equal to 8 8 is 64, 6 6 is 36. It will become 100. So h square is equal to 100. Taking root both sides, we have 100 is a perfect square quantity. 100 can be written as 10 times 10. So pair of 10. So hypotenuse is equal to 10. Hypotenuse and diagonal both are same thing. And diagonal is also 10. So the length of the diagonal in that case is 10. Length of the diagonal is 10 in that case. What about area? Area of rectangle is given by length times width. Length time is means 8 times 6. 8 times 6. 8 times 6. It will become 48. If unit is mentioned, make it square. 48 centimeters square. What about perimeter of rectangle? Perimeter means sum of all sides. Perimeter means sum of all sides. Look at this. If it is our L, it's our L. This is our width. This is our width. Means 2 times L or 2 times W. 2L plus 2W. One can take 2 common. L plus W. This is our length, then it is width. If this is length, then this is width. It's okay. 2 times 8 plus 6. 8 plus 6 is 14. 2 14 are 28 centimeters. So this is our perimeter. This is a formula for perimeter of a rectangle, area of rectangle, and diagonal. Diagonal of this one is given by generally. If I treat this one as x and this one as y, this is our diagonal. Then diagonal square is equal by Pythagoras theorem x square y square. Diagonal is equal to root x square plus y square. Whenever you are interested in diagonal, switch over to this formula. Otherwise, area and perimeter, they are simple. Sum of all sides, 8 plus 8, 2 times 8 or 2 times 10, w plus w, 2 times w. Taking 2 common, right, in that fashion or in that fashion, both are same, they are equivalent. For moving towards circle, look, perimeter means sum of all sides. Perimeter means sum of all sides. In case of circle, there is no side. There is an external boundary. In that case, instead of perimeter, circle has circumference. The measure of this external boundary, the rope-like thing. Area of circle is given by area of circle. It's r pi times r square. Instead of perimeter, we have circumference of circle. This complete round is known as circumference. It is given by 2 pi r, or you can write pi d. Both formulas are identical. Why? Because d is equal to 2r. Instead of 2r, one can put diameter. One can plug in d is equal to r. This is formula for circumference. This is also formula for circumference. In that case, what we given the radius? Diameter is 14. Diameter is given to us 14. Diameter is 14. We are asked to find its area. For area, half the diameter. Half of diameter is known as radius. 14 over 2, 7. 4. So the area of circle is pi times r square. Pi times 7 square. 7 square means 49. 49 pi is our area. What about perimeter? Put direct diameter or radius, both are same. This is the formula circumference 2 pi r, or one can utilize pi d. Both give the same result. Obvious enough. 2 times pi r is 7. 2 7 the 14. So circumference is 14 pi. What about this pi? Diameter is direct 14. It will give us 14 pi. If they are equivalent, they are equivalent. Nothing to worry about that. Final question is based upon cuboid and we asked to find its volume as well as surface area. Okay, let me read this first. Rectangular solid having sides L is equal to 4, length, width and height. And height is 5 centimeter. Height is 5 centimeter. One can complete them 4, 3 and 5. One can complete this figure. I am not good at drawing, but let me complete for you this as well. 3, 4 and height is 5. Height is 5. Volume is simply given by length times width times height. Length, width, height collectively they are known as dimensions. Dimensions. Length, width, height they are collectively known as dimension. It is given to us. Length 3 times 4 times 5 if I am not wrong. 3, 4, 5. Okay. It will become 60 centimeter cube. So the unit of volume is cube. Volume of cube. Surface area. Good formula. Surface area. Surface area is given by twice length into width, width into height plus length into height. Three dimensions are involved. Length, width, height, then length, height. Length, width first, width, height second, then length, height. Look at this. Length, width, height. First take length, width plus width, height plus first and third, length, height. Then twice. Then make this twice. Okay. So our length is 3. Let me write width 4, height 5. Insert values here. 2 times. Our length is 3. 3 times width means 4. Width is 4, height is 5 plus length is 3 and height is 5 in that case. Look at this. 3 2 times 4 2 times I have 8. Okay. 3 4 the 12, 20 plus 15. How much? 32. 32 and 15. 7 1 carry 47. Twice the 47. 47 plus 47. It will become 96. 2 times 47 means 96. 2 times 47 means 96. 2 times 47 means 96. One can calculate that. The formula, just insert values and get the answer. Insert values and get the answer. Insert values and get the answers. Okay, moving towards final questions. Question of function that I have already done in the previous frame. Let me explain to you a question also of this as well. 1 1. The relation is given to us 1 1, 2 1, 3 1, 4 1 and 5 1. Look at this. In this case, nothing has been mentioned explicitly. What do you? It is relation from what to what, from A to B, B to A. Elements are not given. Just check. It's a function. 1 is related to 1. Good. 2 is also related to 1. 3 is also related to 1. 4 is also. Let me draw a Venn diagram of this one. 1, 2, 3, 4, 5. First elements are known as domain. I have written. They all map to. They all are the images of 1. They all are images of 1. This is the function. This is a function, and it is known as constant function. And this is known as constant function because the domain, the image of each element is 1. The image of each element is 1 under the function. Yes, it is a function and known as constant function. Constant function. Constant function. What about next? Next I have 2 1, 2 2, 2 3, 2 4, 2 towards 5. Look at this. 2 to 1, same 2 to, it's violation of this one. Each image has unique image. 2 is mapped to 1. Single input has several output. Look, 2 to 1, 2 to 2, 2 to 3. It's not possible. It's not possible. Let me draw this. This 2 has been mapped to 1, as well as to 2, as well as to 3, as well as to 4, as well as to 5. It's not a function. It's not a function. It is possible. 1 also mapped to 1, 2 to 1, 3 to 1, 4. Like this, 5 people have same age. 5 persons have same age. 5 persons have same age. It is not possible. Same person has 5 different ages. Same person can have how 5 different ages. It is not possible. It is not true. It is not function. Not function. It is function. Unique input, unique output. One has the age 1, it's okay. 2 has also age 1, 3. It is possible. Several people have single age. Several people have single age. It is not possible. Single person can have multiple ages. Single person cannot have multiple ages. It's not a function. Okay, let me explain one more thing for you. In that case, I am taking this C1. I am leaving D for you. It's C, not B. 0 1, 2 1, 3 2, 4 5, 3 1. There is no violation in my opinion. 0 to 1, 2 to 1, 3 to 2. It's okay. It's a function. Let me draw. 0 to 1, cool. 2 to 1, 2 to same one. It's cool. 3 to 2, cool. 4 to 5, impressive. 3 to again 1, same. It is possible. 3 persons can have same age. 3 persons can have same age. It is possible. It is possible. Yes, it is a function. Yes, it is a function. It is a function. So that is tiny concept of function that I have explained to you. Some certs I have written. Some certs I have written. Mostly they are present in exams, and they are troublemakers. How to shoot them? Let's see and find out. 2 times root 28 over 7. Over 7. Look, there is no middle symbol, positive. Here we can apply a table here. From root to 7 for the 28, but in root. It is 2 times root 4. Root 4 can be written as 2 times 2. Here the pair, or 4 is the perfect square quantity having a square root 2. 2 to the 4 is our answer. R1 can take a lengthy approach like a beginner to 28 can be written as 2 to 7 over root 7. 2 times 28 can be factorized 2 into 7. We can write this square root as a distributive. 2 times 2 times root 7 over root 7. Cancelled out. 2 into 2, 4 are pair of 2. 2 times 2, it will become 4. Don't forget, while negotiating root, a times a, it's equal to a. A times a, it's equal to a. A times a, it's equal to a. Or a square raised to 1 over 2. 2 to cancel, we have a. We have a. That is the strategy to deal with the surds. Let's see next question. 3 times root 5 plus 8 times root 5 is equal to what? They are simple enough. Simple enough. 3 times root 5 plus 8 times root 5. Look, taking 5 common, it is going to trouble for you. Just add the coefficient 3 and 8, it will become 11 times root 5. 11 times root 5, and it's our answer. 5 cannot be factorized. Or Look at this. Instead of 5, suppose under root 5 is equal to x. 8 under root 5 is equal to x. Now we can add them 3 and 8. 11 times x. What is the value of x? X is equal to root 5. We put the value. 11 times root 5 is our answer. Or there is one more strategy, whatever you like. 3 root 5 plus 8 root 5. Taking root 5 common, we have left with 3 plus 8. 3 plus 8 means 11. So this one can be written in elegant manner, 11 times root 5. 11 times root 5. Whatever path you want to take, just apply a concept and you are going to get through. What about question number 3? Question number 3 is 5 times root 8 negative 2 times root 8. Look at this. 5 times root 8, 2 times root 8. Don't you worry. Here root 8, 5 minus 2, it will become 3. Simply that's the answer. 3 root 8. Or one can take time. Suppose it is equal to x. 5 root x. It is also equal to x minus 2x. Its standard amount 3x. We put the value of x, that is 3 root 8. Factorize 8. 3 times 2 into 2 into 2. Pair of 2 and a single 2 remains inside. Pair of 2 and a single 2 remains inside. 3 to the 6 under root 2 is our answer. 6 under root 2 is our answer. Or one can take different path by solving individually. 5 times root 8 minus 2 times root 8. 5. Factors of 8. 2 times 2 times 2 minus 2 times a pair from here. 5 times 2, pair of 2. Root 2 remains same. 2 is there, pair of 2 under root 2. 5 to the 10 under root 2 minus 4 under root 2. Taking under root 2 common, we have 10 minus 4. Under root 2 times 6, or one can write in elegant fashion 6 times root 2. 6 times root 2. That is the strategy to negotiate such type of tiny question, but they are troublemakers for beginners. The final question, it's a good one. Now finally we have arrived at the final question. 34 times 23 plus 38 times 20. There must be 23. Look at this. What we have written. There is also 23. Taking 23 common or add these two. 23 root 23 common. We have left with 34 plus 38. 34 plus 38 to 1 carry 72. Root 23 times 72, or one can write 72 times root 23. They can be added. Suppose it is x. X, it is also x. X is equal to root 23. Inside here, you will get 34x plus 38x. 34 plus 38, it will become 72. X, re-put the value of x. 72 times root 20. 72 times root 23, it's our answer. That is my tiny effort, guys, for you to solve mock test for you. These are mock important type of question present, especially in IBA, sucker, or in GAT exams. Sky is the limit and beyond. Let's see and find out what I have next for you. It's all by itself. Next.